Okay, so it says for part E, sketch the graph of f showing clearly the value of the x-intercept and the approximate position of p. Okay, so and it's only for x is greater than 0, by the way, guys. So let's say this is x and this is y. Now I've brought this in from the previous question. It is to show you where, so this was where is this graph positive? Where is it greater than 0? And it's greater than 0 when x is bigger than 1. So it's always going to be bigger than, it's always going to be positive when x is bigger than 1. So well, I think the first thing we need to do, guys, is get the x-intercept. So the x-intercept happens when ln of x over x to the 4 equals 0. And it's kind of the same way we would solve this. Ln of x equals 0, x equals e to the power of 0, which is 1. Okay, so the x-intercept is at 1. We also know we have a maximum at e to the power of a quarter. Now that's the fourth root of e. So the fourth root of e, guys, just for so that you're all aware, that's going to be bigger than 1 because e is 2.718, whatever. The fourth root of it has to be bigger than 1 because otherwise how else are you going to get to 2.7? If it was less than 1, it just gets smaller. If it was equal to 1, it just stays at 1. So it has to be bigger than 1. So it's going to be bigger than 1. Let's just say over here somewhere. What is it? I don't know without my calculator, but it's bigger than 1 over here somewhere. And 1 over 4 to the e, let's just put that wherever. So this is going to be p, which is e to the quarter, comma, 1 over 4 e. So it says showing clearly the value of the x-intercept, done, and the approximate position of p. So yeah, he said approximate because as long as it's to the right of 1 and in the positive a positive y coordinate, then you're good. Okay, so to sketch the graph now, as x, so x has to be bigger than 0, but as x approaches 0, this thing ln of x is negative, and this thing we're dividing by a really small number, so it gets really, really big. So that's just there's going to be an asymptote at 0, but it's going to approach negative infinity. So I'm going to do this. Let me try and do that again. Okay. Then it's going to go up here, and this is a maximum. So this is going to turn here. Now what happens at this point, as x gets very, very big, so imagine x is, I don't know, 100, or let's even say 10. When x is 10, the numerator is 10 times 10 times 10 times 10, which is 10,000. And the denominator is ln of 10, which is actually not that big a number. It's like, I would imagine it's 2 point something. It's really not a small number. And remember, ln of x grows very, very slowly. So basically, as x gets big, this thing approaches 0, but it always stays positive because of this thing. Remember, guys, we said this function is always positive when x is bigger than 1. So what's going to happen is it's just going to come down, and then well, let me do that again, guys. There's an asymptote at y equals 0, or on the x-axis. So it says here, show the value of the x-intercept clearly and the approximate position of p. So you're going to get one mark for this, 1 mark for this, and another mark for just the approximate shape. They're not that fussy that you show this point of inflection, or you don't even have to write the equation of the asymptote, although I'm going to write that anyway, just more information is better. Asymptote at y equals 0. So that just gives them a bit more information. And actually, when x is 0. So horizontal asymptote at y equals 0, vertical asymptote at x equals 0. Okay, that's question 8.